Hey there. In this video, we're going to talk about expected value, or the mean of a random variable. So this will be a quick one. Let's get at it. All right. Oops. Oh, there it is. Here we are. Expected value. Now, in this chapter in the book, and by the way, let me... there we go. In this chapter, they also talk about how to compute the standard deviation of a random variable. I'm not going to go there. All right. It's not that hard, but I think we'll keep things simple, okay? So let me get out of the way here. I think here's some space. What is the expected value? The expected value is the number, most values of the random variable will be near, on average, right? So it's also called the average of the random variable. So if I do something many times, like rolling a die, right? If I keep rolling this die, I can get all kinds of numbers here. On average, what are most numbers closest to? If I can come up with one number that best, averages all these different values I'm getting, what would it be? All right, so that's the expected value. How do we compute it? Well, we look at the outcomes of x. So these are the numerical outcomes that x could have, all right? And these are their associated probabilities. All right. Well, then the mean, or expected value, same thing, is given by, it's the sum of each outcome multiplied, I should say multiplied, by its corresponding probability. All right. So mu, that's the mean, or expected value, that's the notation that we use, is this sum. This is the mathematical symbol for sum. We're taking each value and multiplying it by the probability, adding them up. So written out, this is what it would look like. The first value multiplied by its probability, plus second value by its probability, plus third value times its probability. Keep going. Just add them all up. Okay? So let's do an example. Let's roll a die like I just did. All right? What is that expected value? All right? What? There it goes. What is the expected value of all these rolls? All right? Well, here's what I would do. All right, I would let x denote the value of the roll. Let's figure out what our random variable is first. All right, and now let's go ahead and do this computation. So the expected value of x is each of its outcomes. So its outcomes are the numbers 1, 2, 3, 4, 5, or 6. Those are the numbers I can get here, right? And I multiply each one times the probability of getting that outcome. So that's what I've done here. I've multiplied each outcome by its probability. Now, what are those probabilities? Well, if you remember from the last video or from discussions before, or just by knowing how to compute probabilities from equally likely outcomes, you know that each probability is 1/6 in this case. So I'm just multiplying each one of these numbers by 1/6 and adding them up. Okay, what do I get? I get 3.5. So that is the number that falls right in the middle. And if you listed the numbers 1 through 6, 3.5 is dead in the middle, right? So that should make intuitive sense, right? Let's do another one. A gambling game involves rolling a die. Okay, the game costs $5 to play. If you roll a 6, you win $10. If you roll an odd number, you win 5. Get your money back. If you roll any other number, you win nothing. All right? So what is your expected profit in this game? And then, how much would you expect to earn or lose if you played this game 50 times? Okay? So think about it. And just get a just try to make a guess here. Like, do you think that this would be a worthwhile game to play? Do you think in the long run you'd be making money or losing money? All right. Well, this expected value is going to figure that out for us. This is where expected value can be really useful. And casinos do expected values all the time to determine, answer exactly these questions. Are they going to be turning a profit? Okay, well, how are we going to do this? Well, let's name our random variable. Okay, so x. And what is it going to denote? It's going to denote how much we win. All right? So the possible values that we can win are 0, 5, or 10. Those are the amounts that we could win here, as was described, okay? So to compute the expected value of x, I'm going to take these values and multiply them by their associated probabilities. All right? So according to the expected value formula, I'm going to take each value, multiply it by its probability, right? Now, what are those probabilities? Well, I said the probability of getting a 10 was 1/6. Why is that? Because to get $10, you need to roll a 6, right? What's the probability of rolling a 6? It's 1/6. Probability of rolling any number on a die is 1/6. All right, and then what about the probability of winning $5? Well, let's see. How do you win $5? By rolling an odd number. What's the probability of rolling an odd number? It's 3/6 or 1/2, right? But I put 3/6 here because I want a common denominator so they're easier to add, right? And then 0 is the other amount that I could win. I'm going to multiply that by the probability that I win 0. What's the probability that I win nothing? If you roll any other number. So that means I rolled anything but a 6 or an odd number, right? Well, there's only 2 other possibilities left. It's a 2 or a 4. The probability of rolling a 2 or a 4 is 2 out of 6 because there's only 2 numbers. So this is how I compute the expected value. I'll just do the math here. And when I add these up, 25/6 or 4.17. So on average, if I played this game many times, I will on average win about $4.17. Does that mean that's what I'll win every time? Absolutely not. Sometimes I'll win $10. Sometimes I'll win 0. But on average, I'll win this amount. All right? So since we paid $5 to play, what's our expected profit, right? Don't forget, we paid $5 to play this game. So we actually have to deduct the amount that we paid. So look what's actually happening. We're actually losing 83 cents on average every time we play, right? So we're actually not coming out ahead here. Okay. Now, how much would you expect to earn or lose if you played this game 50 times? How would I compute that? Well, what do I have to do here? Well, I'm losing on average 83 cents per game, right? Well, if I play it 50 times, I'd be losing 83 cents times 50. What is that? So that's, let's just do that in a calculator here. 83 cents times 50. $41.5. Now, this is a negative number, right? I'm losing that amount. So I'm actually going to lose $41.50 if I play this game 50 times. Well, not necessarily. I may not lose that. I might get lucky and come out ahead. But I can expect, on average, if most people, if they played this game 50 times, this is what you would expect them to lose. $41.50. Okay? So that's a good use of expected value, and you better believe this expected value is what gamblers use to figure out what bets to make, and what casinos use to figure out how to rig their games so that the casino will always come out ahead, because the casino is not going to let this happen. They're always going to arrange it so that they have a plus sign here. Okay, so that's it for this video, expected value, and I'll see you in the next video.